Howdy and welcome back. In the last video, I explored third-party trust in the fiat banking system as a precursor to understanding the features of the Bitcoin protocol. The point was to provide examples of how transactions occur in a system that's familiar to you. I now want to transition from the broad concepts of this trust-based system to the features that implement many of the same concepts in a trustless system. It turns out that many of the concepts from the trusted system carry over to the Bitcoin protocol. Of course, the difference is in the implementation. Not surprisingly, the Bitcoin protocol implements many of these same concepts in a way that doesn't require trust. For example, a bank is entrusted with account creation, which identifies a participant in that system. The implementation of the trusted system requires the bank as an intermediary to administer account creation and account validation. Bottom line, participants entrust the bank to make identity work. The Bitcoin protocol uses public keys and hash public keys as features that implement identity. In this system, anyone can create a public key and therefore an identity. Permission from an intermediary is not required, and this is one of the many differences between a trusted system and the Bitcoin protocol. It illustrates the similarities and differences between the concept of identity in a trusted system and identity implemented in the Bitcoin protocol. The end result is the same, however, the trade-offs in terms of trust are very different. Now, until I get into the nitty-gritty of how public keys and hash public keys are used to create identity, it won't be completely clear how the two systems are different. I guarantee, though, that when I get into the math portion of this discussion, you can verify for yourself whether these statements are accurate. For now, it's just important to recognize the conceptual distinctions between trust and trustless systems. Many of the concepts and related features of the Bitcoin protocol rely upon each other to function, and that presents a problem. How does one learn multiple concepts and features at the same time? And the short answer is, you don't. Instead, when I introduce new concepts and features, I'll provide context for where it fits in the big picture. And to create this big picture, I'm going to borrow from Douglas Adams, author of The Hitchhiker's Guide to the Galaxy. In it, he imagined something called the total perspective vortex, which would allow anyone who entered the vortex a way to see where they fit in the universe. I'm trying to recreate a total perspective vortex for the concepts and features of the Bitcoin protocol by providing context for where a concept or feature fits into the overall protocol with a "you are here" symbol. I'm starting with the original question of how to transfer control of Bitcoin from Alice to Bob without the need of a trusted third-party intermediary. So from this humble little symbol, you can trace a feature up to the concept being implemented, or from a concept down to the feature and ultimately the math used to implement it. Most of the Bitcoin protocol features may be new to you, but I think seeing them together in context now will help when they're later described separately in more detail. I've renamed my Vortex the Bitcoin Protocol Feature Requirements Model. The name pales in comparison to the Total Perspective Vortex, but over the course of examining the entire protocol, I'll continue to update this model with a goal that in the end, I'll have a complete visual representation of the protocol. Finally, I want to demystify the term protocol, as in Bitcoin protocol. In this context, protocol simply means a set of rules followed by a bunch of folks that are implemented and enforced via a set of computer applications. The applications are executed by all those participating in the system, which in turn results in Bitcoin's perceived value. A question I get immediately after providing this explanation is, why can't I just change the rules? And the short answer is, you can. However, if you can't convince others to follow your new rules, then the value of your change is worthless. Therefore, if you submit a change that only benefits yourself, the chance of others following it is nil. That doesn't mean the protocol is fixed in stone. Far from it. Proposed changes are submitted regularly, but only after careful deliberation is a change implemented. And once implemented, if the change isn't backwards compatible, also called a hard fork, everyone participating in the network must upgrade their applications, or the network splits into two different forms of Bitcoin. So don't get confused by the term protocol, and remember that I could have called this video series Fundamental Bitcoin Rules instead of Bitcoin Protocol Fundamentals. In the next video, I'll introduce a key feature in the Bitcoin protocol, the transaction. If you found this video helpful, please click the like button as well as the subscribe button. Thanks again for watching.